Hello students, this is Advanced Math, Saxon Advanced Math Lesson 46, Factoring over the set of complex numbers. Quadratic equations. We've been studying quadratic equations and they are of the form ax squared plus bx plus c. We have learned to solve these equations. The solutions are also known as the roots of the equation. Some quadratic equations can be factored, and the roots can be found by setting each factor equal to 0. For the rest, the equations that cannot be factored, we use the quadratic formula to solve for x. In advanced math, we will learn to find the factors of the rest, the quadratic equations that cannot be factored. Some quadratic equations can be factored. Here's one that can be factored. 2x squared plus 6x minus 8 equals 0. The first step is to get the x squared coefficient to be 1. So in this case, the 2 is a factor and we don't want to lose it. So we factor that out and we're left with x squared plus 3x minus 4 equals 0. Now we finish factoring and we end up with 2 times x plus 4 times x minus 1 equals 0. I'm putting the factors in blue in this presentation. The equation is factored and now we can determine the roots. X equals minus 4 and 1. We obtain that by setting x plus 4 equal to 0 and by then setting x minus 1 equal to 0. I'm sure you're familiar with this. Factors are part of a multiplication problem. 2 times x plus 4 times x minus 1 gives us back our original quadratic equation, 2x squared plus 6x minus 8. The roots are the solutions to the equation. X equals minus 4 and x equals 1. So here's our equation again. This equation has 3 factors and 2 roots. The 3 factors were 2, x plus 4, and x minus 1. The 2 roots are minus 4 and 1. If I seem to be belaboring this point, bear with me. Notice how we can get the factors containing x from the roots. X minus a root equals a factor. For example, x minus minus 4 equals x plus 4, which is a factor containing x. X minus 1 equals x minus 1, which was the other factor containing x. The third factor, 2, cannot be found in this way. You're going to be learning how to find the factors that contain x. So there you have it. X minus a root equals a factor. This is our key to factoring over the set of complex numbers. To factor these quadratics, we work backwards from their roots, which we obtain by using the quadratic formula, because remember, these are the ones that cannot be factored. After we obtain the roots, we apply our new key to find the factors. These problems can be a trap because you are used to being finished after you find the roots, the solutions of an equation, when you're using the quadratic formula. You must keep in mind that the new purpose is to determine the factors, and finding the roots is only a step in that process. My head is definitely in the way. Example, factor 3x squared minus 9x plus 12. Step 1, Factor out the 3, but don't forget about it. So that leaves us with 3 times, in parentheses, x squared minus 3x plus 4. The 3 is a factor. Using the quadratic formula, we find out that the roots of x squared minus 3x plus 4 are 3/2 plus the square root of 7i divided by 2 and 3 over 2 minus the square root of 7 times I over 2. Those are the solutions to that equation. Now we can find the other 2 factors. They will be x minus a root equals a factor. X minus 3/2 plus square root of 7i divided by 2 and x minus 3/2 minus the square root of 7i minus 2, little mistake there, gives you the two more factors. X minus 3/2 minus the square root of 7i over 2 and x minus 3/2 plus 7, the square root of 7i divided by 2. Therefore, factor over the complex numbers means that you have a quadratic equation that cannot be factored. We just learned that it can be factored. It does have factors. It's just that the factors contain complex numbers. Factor over the complex numbers, the steps. This is summing up what is in this video. Step 1, factor out any constant but keep it. It's one of the factors. Step 2, use the quadratic formula to find the roots of the equation. And step 3, find the factors by applying this key. Factor equals x minus root. I hope this video has helped you to master Lesson 46. We'll see you next time.